What's up, everybody? Moving on to the next example, we have f of x is equal to the square root of 4x minus 3, and there's two parts to this question. Number one, we have to find the derivative, f of prime x, and then number two, we have to find the equation of the tangent at an x value of 3. So to do number one, we know that f of prime x is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. Now f of x plus h, we would just take that x plus h and plug it into the x value of the function. So we'd end up with the square root of 4 bracket x plus h minus 3. And then we're subtracting f of x, which is just the square root of 4x minus 3. And then this is still all over h. Now notice how in this limit we can't just plug in 0 for h because the denominator would be 0. So what we have to do is we have to somehow simplify this numerator. And because there's these square roots involved, we know we have to rationalize that numerator. And because it's a two-term radical, we have to multiply it by its conjugate. So then the conjugate of these two terms here is just those two terms kept as they are, but we change that sign in the middle to a positive. And then we put the conjugate in the denominator as well. So it's like we're taking this expression and multiplying it by 1. And then when we multiply the numerators, notice how we just have to multiply the n terms because we're multiplying an expression by its conjugate. So multiplying these two n terms, we just end up with 4 bracket x plus h minus 3. Basically, just the square root goes away. And then we're subtracting that term 4x minus 3. The square root of that goes away as well. And then in the denominator, when we multiply these two terms, let's just keep them separately. So the h is here. And then this whole term is right here in the bracket. So then continuing on over here, if we simplify that numerator, distribute the 4 inside the bracket, distribute the negative inside the bracket, we would just be left with 4h in the numerator. The denominator stays the same, and now notice how these h's cancel out. And now we can just plug in 0 for h, because that h in the denominator went away. And notice the only h that's remaining is this h right here. So if we plug in 0 for h there, we would be left with 4 over the square root of 4x minus 3 plus the square root of 4x minus 3. So then when we add those square root of 4x minus 3's together, because they're like terms with coefficients 1 in front, we would just end up with 2 square root of 4x minus 3 in the denominator. And then notice how 2 goes into 4 twice. So our final answer is 2 over the square root of 4x minus 3. So this here represents the derivative for this function, the square root of 4x minus 3. The next question, we have to find the equation of the tangent at an x value of 3. And to do that, I thought we'd start off with a visual representation of what this question is asking us to do. So this here represents the graph f of x, where f of x is the square root of 4x minus 3. And then here, this x-intercept is 3 over 4. And the way we got that, we can just rewrite this equation. If we take the 4 out, we got x minus 3 over 4. So it's like we took the parent function, the square root of x, and then shifted it over by 3 over 4 units. So now what we have to do is we have to find the equation of the tangent on this function at an x value of 3. So let's say an x value of 3 is right there. So if we draw a tangent at that x value of 3, it's going to be this blue line here. So we basically have to find the equation of this blue line at an x value of 3, the tangent on the function. Now, we know that because it's a line, our final answer is going to be in y equals mx plus b form. That's basically the equation of a line. Well, the first step, we have to find that m value, the slope. But we know that the slope of a tangent on a function is just equal to its derivative. And we know that the derivative of this function we found in part 1, it's equal to 2 over the square root of 4x minus 3. But we need the slope of the tangent at that specific x value of 3. So if we plug in that x value 3 into the derivative, f of prime 3 would be 2 over 3. So this 2 over 3 here represents the slope of this tangent, the slope of that blue line. So we have step 1 figured out. We have the m value of the line. And then the second step, we have to find that b value in the line. And to do that, we would take that slope, 2 over 3, which I subbed in for m, and we need a coordinate on this line to plug in for x and y, and then we can solve for b. So the coordinate that we can use on this tangent line is the coordinate that this tangent is touching the function at. So we know that the tangent is touching the function at an x value of 3. Well, what's that y value going to be on the function? Well, we can just plug it into our original equation. So f of 3, if we plug in 3 for x here, we'd have 4 times 3, which is 12 minus 3, 9. Square root of 9 is 3. So we know that on this function f of x, we are finding the equation of this tangent at a coordinate 3 and 3. And now we can just take that x and that y value and plug it in here and then solve for that b value. So our y value is 3, and then 2 over 3 times 3 plus b. Notice how the 3's cancel out, so we just have 3 minus 2 equals b, so we know our b value is 1. And now we have the final equation of that tangent line. It's basically 2 over 3x plus 1. So that there is our final answer for question 2. So as a quick recap, whenever you're finding the equation of a tangent, 2 steps. You have to find the m value, and the m value, the slope of that tangent, you can just use the derivative of that function you're working with. And we found the derivative in part 1. It was 2 over the square root of 4x minus 3. So at that specific x value of 3, the slope of the tangent, if we plug in 3 into the derivative for x, then we'd get that slope of 2 over 3. So the slope of this tangent is 2 over 3. And then we have to solve for that b value in the linear equation. So we need a coordinate that we can plug in, x and y. Well, we know at an x value of 3, a y value of 3 would occur on this function. So we just plug in 3 for x, 3 for y, simplify, we get that b value of 1. So then our final equation of the tangent is y equals 2 over 3x plus 1. Yo, what's up guys? Thanks for checking out my channel. Hopefully you got some value from the video you just watched. If you did get some value, big favor to ask you, please like this video and subscribe to the channel. Any questions, any recommendations on things you'd like to see, please leave it in the comments section. Also check out the description box below for links to material and content related to the video you just watched. Peace out.